Principles Show daily podcast by and for you.
All right, so strap yourselves in, folks, because today we're diving headfirst into something pretty major happening over in China.
Yeah, a real game changer, potentially.
We're talking about China's engineering future, but not in the way you might think.
No, not bridges or high-speed rails this time.
This is about how they're literally changing the way they train engineers at the highest levels.
Right, from the ground up, yeah.
Fresh off the press, October 30th, 2024, we got these guidelines straight from the BRICS joint website.
Professional Doctorate Applications in Engineering. That's the official title.
Sounds a bit dry, but trust me, this is juicy stuff.
Oh, absolutely. It's like they took the old PhD playbook and tossed it out the window.
And replaced it with something way more hands-on, way more focused on results.
Exactly. Instead of spending years writing a theoretical dissertation, imagine building a working prototype.
Or designing a whole new system, something that actually solves a real-world problem.
That's the idea. It's almost like how medical students have residencies.
Yeah, like an engineering residency where you're out there in the thick of it, learning by doing.
And it's not just some China-specific thing either.
This is tapping into a huge global shift. I mean, think about it. Companies everywhere are screaming for graduates who can actually do things, not just talk about them.
It's not enough to just have the theory anymore.
You got to be able to build, design, innovate, make things happen in the real world.
Companies need problem solvers, not just academics.
So these new guidelines, it's kind of like China saying, hey, world, we're listening. We're going to make sure our engineers are the best, the most practical, the ones who can hit the ground running.
It's a power move for sure, and the rest of the world is definitely watching.
They're watching and probably taking notes.
Yeah, because this could be a sign of things to come, a whole new way of thinking about higher education.
Okay, but let's get specific here. What exactly are these practice-oriented outputs they're talking about? Instead of a dissertation you could create.
Well, they mention things like detailed designs for complex engineering systems. That's one.
So blueprints for something big and complicated, something that would actually work in the real world.
Yeah, exactly. Or developing a brand new material, a new process for manufacturing, that kind of thing.
Stuff that could actually have a patent on it, right?
Exactly. Patents, maybe even spin-off companies coming out of these doctorates. It's a whole different ballgame.
And it's not just limited to like one tiny corner of engineering either. This covers a whole bunch of fields, right?
8, to be exact. It's pretty broad.
8 major categories. Lay it on us. What are they?
Okay, so we've got electronic information, mechanical engineering, materials and chemicals, energy and power engineering, civil engineering, environmental science and engineering, bioengineering and biomedical engineering, and mining and metallurgical engineering.
Well, they're not messing around, are they? This is across the board, basically a whole new generation of engineers.
A generation that's trained to be builders, creators, innovators.
Okay, so out of that whole list, let's pick one, just to get a sense of what this could look like in practice. What about, say, bioengineering?
Bioengineering, good one. I mean, think about all the challenges we're facing in healthcare.
Yeah, aging populations, chronic diseases, the need for personalized medicine, all that.
Exactly. Huge problems that need creative solutions.
Right.
This is where those hands-on doctorates could really shine.
Imagine a doctoral student, instead of writing papers, they're actually developing a new prosthetic limb.
With advanced functionality, maybe even using AI or something.
Or what about breakthroughs in tissue engineering? Imagine growing organs in a lab.
That's the kind of stuff we could be seeing coming out of these programs.
It's like the future of medicine, but engineered by these new doctorates.
And then you've got energy and power engineering, another huge one.
Oh yeah, the world needs clean energy solutions like yesterday.
Exactly. We need to combat climate change. We need sustainable ways to power our lives.
These new doctorates could be like the breeding ground for breakthroughs in solar, wind, energy storage, all that.
I mean, the possibilities are pretty mind-blowing.
It feels like we're on the verge of a whole new wave of innovation, and these engineers are going to be riding the wave.
It's exciting, but also kind of makes you think.
About what?
Well, if this works in China, could we see a similar shift globally? I mean, is this the future of engineering education everywhere?
That's a big question, and one we're going to be tackling in the next part of our deep dive.
Can't wait to dig into that.
But before we get ahead of ourselves, let's not forget there are always two sides to every coin.
Yeah, there are definitely potential challenges and downsides to consider too.
So let's flip the script and talk about those what could go wrong. What are the risks of this new approach?
That's where things get really interesting, so stay tuned.
Oh yeah, there are definitely some potential bumps in the road. It's not all going to be sunshine and roses.
Okay, so let's play devil's advocate for a minute. What are some of the things that could go wrong with this whole approach? What makes you nervous?
Well, for one thing, there's the risk of like swinging too far in the practical direction. You mean like losing sight of the importance of fundamental research?
Exactly. If everyone's obsessed with building the next gadget, who's going to be pushing the boundaries of theoretical knowledge?
It's that classic tension, right, between knowledge for its own sake and knowledge for a practical purpose.
Right. And look, applied skills are obviously important, but you can't just ignore the theoretical foundations.
Otherwise, you end up building a house on sand.
Exactly. Eventually, the cracks are going to start showing.
So these programs, they're going to have to find that sweet spot between theory and practice.
That's the challenge, isn't it? How do you balance those two? How do you measure success when it's not just about publishing papers anymore?
Yeah, how do you grade a startup, right? Alongside like a deep understanding of thermodynamics or whatever.
It's a whole new way of thinking about assessment for both the students and the faculty.
Like, imagine trying to explain to your parents that your PhD is now a successful app.
Right. Or a new type of solar panel.
So universities are going to have to figure out how to evaluate these practice-oriented doctorates, and that's not going to be easy.
It's uncharted territory for sure. There are going to be some growing pains.
Okay, so that's one potential downside. What else? What else keeps you up at night?
Well, another thing that worries me is like, what about those really out there ideas? The ones that might seem crazy at first, but could lead to huge breakthroughs.
Yeah, if you're too focused on making something marketable, you might miss out on those truly innovative ideas.
Like, imagine if the people who invented the internet had been pressured to create something profitable right away.
We might all still be using dial-up.
Exactly. So these programs need to make sure they're not stifling creativity.
They need to encourage risk-taking, allow students to explore those unconventional paths.
Because that's where the real game-changing discoveries often come from.
It's like you need to balance that drive for practical results with a healthy dose of intellectual curiosity.
Yeah, you need both. It's a delicate dance.
Okay, so potential for less fundamental research, potential for stifled creativity, anything else?
Well, this one's a bit trickier, but it's about fairness.
Fairness? How so?
Well, not all students have the same advantages, right?
Some come from families with more resources, more connections, that kind of thing.
Exactly. So if you're asking students to launch startups as part of their PhD, well, some are going to have a much easier time than others.
Like, imagine trying to build a company while also dealing with financial stress or family obligations.
It's not a level playing field.
So these programs need to be really careful about equity. They need to make sure they're providing support to students from all backgrounds.
Yeah, otherwise you're just going to end up widening the gap between the haves and the have-nots.
Okay, so we've talked about a lot of potential downsides here, but let's not forget there's also a huge potential upside.
Oh, absolutely.
Yeah.
If China pulls this off, if they get that balance right, the benefits could be massive.
Talk to me about that. What's the best case scenario here?
Well, imagine a wave of new technologies, new businesses, new solutions to all sorts of problems.
All coming out of these innovative doctoral programs.
It's like planting seeds for a future we can't even fully imagine yet.
And it's not just about individual students' achievements, it's about the ripple effects.
Those innovations could transform entire industries, whole communities, even the world.
These graduates could become leaders in their fields, driving progress in healthcare, energy, you name it.
It's a vision of engineers as not just problem solvers, but also creators, visionaries, entrepreneurs.
People who are equipped to tackle the biggest challenges facing humanity.
That's the power of education, right? To shape the future.
Makes you wonder, if China succeeds, could this spark a global shift in higher education?
Could other countries follow suit, start blending theory and practice in their own programs?
That's a question we'll be exploring in the next part of our deep dive.
It's going to be a fascinating discussion.
But before we get ahead of ourselves, let's remember we're still in the early stages here.
This is a massive experiment, and there's a lot of uncertainty.
We can speculate all we want, but ultimately, time will tell how this all plays out. Okay, so we've talked about the good, the bad, the potential upside, the potential for disaster. But like you said, it's a big experiment.
A big one, yeah.
So what should we be watching for as this unfolds? What are the signs that'll tell us whether this is working or not?
I think the most obvious thing to look for is like the actual output.
The results, yeah.
Exactly. What kind of projects are coming out of these new programs? What are these graduates creating?
Are they filing patents?
Yeah, patents, spin-off companies, maybe even whole new industries popping up.
The kind of stuff that makes you go, whoa, where did that come from?
Exactly. And beyond individual inventions, I think it'll be interesting to see how this impacts China's position in the global innovation landscape.
Like, do they start pulling ahead in certain fields?
Right, are they setting the trends instead of following them?
And then the big question, how will the rest of the world react?
Yeah, will other countries try to keep up? Will we see a global shift towards more practical doctorates?
It's like, if one country finds a new way to bake a better cake, everyone else is going to want that recipe.
And that raises a really interesting philosophical question, I think.
Go on.
What is the purpose of higher education, really?
Yeah, good question.
Is it about pure knowledge, or is it about equipping people to solve real-world problems?
I mean, that's a debate that's been going on forever.
Right, but I think China's experiment is forcing us to look at that question in a new light.
It's challenging the traditional model of what a PhD should be.
And it's a good reminder that education isn't static, it has to evolve.
It has to adapt to the changing needs of the world.
Like any complex system, whether it's nature or the economy or education, the key is adaptability.
You got to be able to roll with the punches, learn from experience, keep changing.
Otherwise, you get left behind.
Well, this has been a fascinating conversation.
I've really enjoyed it.
And I feel like we've only just scratched the surface.
Yeah, there's so much more to explore here.
This is a story that's just getting started.
It's going to be really interesting to see where it goes.
But for now, we've got to wrap things up.
Okay.
So, to all our listeners out there, thanks for joining us on this deep dive into China's engineering revolution.
Hope you found it thought-provoking.
We certainly did.
And remember, the world is changing fast.
So stay curious, keep learning, and who knows, maybe you'll be the one leading the next big revelation.
You never know.
Until next time, this is The Deep Dive, signing off.